Hello and welcome back to another episode of the Job Hunter podcast. I'm your host, Tim French, and before we get started, I just want to say a massive thank you to each and every one of you listening for taking the time to actually get invested and listen to the show and build this little community. I really do appreciate it, and it means an awful lot to me, and I just want to say a massive thank you to you guys. So let's get going. This week, we're getting slightly more technical as we'll be looking into the interesting world of 3D printing, what's involved, how it works, and we'll be discussing some of the finer points with a true expert. I really do hope you've been enjoying the show so far, and if you want to get in touch, I'll let you know how to do that at the end of the show. But for now, sit back, relax, grab a cuppa, and let's get on with the music. Welcome back to the Job Hunter podcast. Today, I'm delighted to welcome Matt Williams. Matt is an applications engineer at Renishaw, which is an engineering company based in Gloucestershire. Matt is a bit of an expert in 3D printing, so we'll be talking to him all about 3D printing, what it is, how it works, and what you shouldn't print on a 3D printer. Matt, why don't you start us off by giving a bit more of a background on you, and also if you could tell us what exactly is 3D printing? I'm sure many people know about it from those YouTube videos and TikToks of people making weird stuff out of plastic. But what else can you do with 3D printing?
Yeah, so I started at Renishaw on the graduate scheme as an applications engineer. Quickly dropped off that. I think it was about after a year into a design development role in our additive manufacturing division, where it was actually group engineering back then. I started off that department, then did metal printing and polymer printing, so saw both sides of the world there. And then earlier this year, we branched off the plastics. That's now in a separate division, and now we work purely on metals, so titanium, stainless steel, cobalt chrome, Inconels, stuff like that.
So you've said that you do metals and plastics, but obviously I don't imagine you make them in the same way. I think most plastic printers work by melting the plastic and then laying them down layer by layer, but you can't really do that with a lot of metals, can you? Because you can't get them hot enough.
Well, it does work in a layer by layer method. However, we use 500 watt lasers to melt the metal powder in 30 or 60 micron generally, and build it up in 2D layers into a 3D part in your hand.
So it's basically like you take sections and sections
to
build it up into a full shape.
Yeah.
That's interesting. So would you say that's the main thing, that your printers vary from, say, like a more off-the-shelf version from Amazon, or is there anything specific that yours do?
Yeah, the ones off Amazon and stuff like that generally work via filament. So they melt in a sort of little rod of plastic and then building it up in the 2D layers. But you can also get sort of inkjet-based polymer printers and also powder-based as well. But they use different types of methods of actually melting the pieces together or fusing them.
And what kind of stuff can you make on them? You know, is it literally your whatever you can think of, or is there certain limitations to it?
You do need to have an idea of design for additive manufacturing, especially in the metal side of things. Due to the temperatures that you're melting the metals at, it causes a lot of stress to be induced in the part. So you need to take into account whether the part's going to peel up off the substrate plate, or whether there's an overhanging feature and stuff like that, which would need supporting. And if you don't support those areas, then you end up with bits of metal just sort of flying about.
So what kind of stuff is Renishaw making at the moment? What's the main kind of purpose you've got for these additive manufacturing tools?
We make quite a variety of things. So we've had stuff in F1 cars. We've got stuff going through aircraft certification. We have stuff for the America's Cup boat, which was a project I've been heavily involved in, which starts sailing next week. So that was for Ineos. Not next week, sorry. Oh yeah, it is. Yeah, next week. So we've made probably 30 unique parts of that, some ranging, sort of 200 millimeters tall, but then others, sort of 60 millimeters, but very thin wall sections down to sort of 2 mil, stuff like that.
So what's the benefit of doing it by 3D printing over making it out of, machining out of a big piece of metal?
Well, one, we can have rapid design iteration. So that means they can tweak the design and we can then print it and have parts with them within days generally, depending on how big the part is. It also allows for topology optimization. Therefore, you can run it through software and remove material which doesn't really need to be there and won't affect the mechanical properties. And in some circumstances, by topology optimization, we actually improve the mechanical properties and reduce deflection and stuff like that.
So what's topology? Sorry if I'm playing dumb.
So topology optimization is you can run it through some software and it basically selects material that it deems sort of not required. So then it creates a shape that is generally quite organic in a way, but produces a really strong part.
So it's lighter and stronger.
Yeah, exactly.
Made out of a solid bit. And obviously in a lot of these places, like you said, Formula One, I imagine lightness is their key consideration, isn't it?
Yeah, completely. We do sometimes have to machine our parts depending on the end use. So there is always that option as well. But generally, the stuff we do print for aerospace, the Ineos boat, the F1 cars, they cannot be made in any other manner due to the shape of them.
And so you've talked about, obviously, you've mentioned the America's Cup boat that you've worked on, and you mentioned their Formula One stuff, but has there been anything in particular that stood out to you in terms of projects you've worked on or stuff that you've made already, or, is there things that you're particularly proud of?
Quite a lot of this stuff I can't really talk about, unfortunately. So the bit I'm probably most proud of is working on the Ineos project. That's sort of been the one that I can fully talk about. There's quite a lot of press releases that Redshaw have done about them. So printing that and getting them on the boat for Ben Ainsley's been, a massive achievement.
Did you manage to get down and see the boat, or is it something that you've kind of done from Bristol? Sorry, from Gloucestershire.
We did go down there for a sort of interview day the other day, but it was sort of all under wraps because they were just about to ship it over to New Zealand. So unfortunately didn't really see the full boat, just saw the hull.
So it seems that Renishaw's kind of got their fingers in many pies in terms of the different sectors they're involved in. What would you say is like a big growth area? How do you think that 3D printing will help to kind of change the world in the future? Do you think there's areas that are relatively unexplored when it comes to 3D printing?
I think it's going to be a big breakthrough in aerospace over the coming years. People are building bigger 3D printers so that you can build bigger parts. But it's also actually the certification process of getting stuff into the air is so long. So even though the technology is, relatively old, quite a lot of that time has been done on certification. Our parts are generally better than cast parts. We have far less porosity. We're working to 99.95% dense, and the mechanical properties are great on our parts.
So do you think that, if you were to get on a flight tomorrow and they said, you're flying on a brand new plane and it's full of these 3D printed parts, do you think that someone who's flying on that plane should be worried about that? Or do you think they can kind of have some confidence in knowing that it's safe to fly on?
Yeah, not at all. Yeah, completely safe. Absolutely.
And what do you think is like the key reason that 3D printing has become so kind of fashionable at the moment?
I think it's all stemmed from the desktop printers. So that's sort of raised awareness there. But now more and more companies are delving into metals. There's quite a few other competitors that are in the metals. We're generally one of the smaller companies working on it. But yeah, I think it's just as technology is improving, costs are reducing, productivity is improving. Our 500Q system uses 4 lasers but our original system only used one. So we've essentially quadrupled our productivity by adding 4 lasers there straight away.
And I was going to say, are there any drawbacks to this at the moment? Cost wise or anything like that? Is there anything that you have to say we need to work on that a little bit more in terms of cost or materials?
Yeah, sure. I think there's always improvement to try and reduce the costs. Our powders are not very cheap because they have to be gas atomized to reduce the oxygen content within them. The machines could probably be cheaper as well, but quite a lot of that, a massive amount of the machine cost is actually development time. So we have to we design these printers over many, many years. So getting the cost back on that is huge.
And speaking a bit more about Renishaw, you mentioned that you start off in the graduate scheme. What exactly is that graduate scheme for anyone that might be interested in it?
There's a few different routes that you can go down. So we've got a manufacturing division. We've got sort of our marketing and HRE sort of stuff like that. And then we've got applications engineers as well. So there's a few different streams that you can go down. I think we took on about 40 this year potentially. So it's always, there's always places available. But Renishaw itself actually started off as a metrology company. So metrology is measurement. So we made the first touch sugar probe back in 1983, I believe. And then we've just made our own coordinate measurement machine, and we make our own encoders with gold scale and stuff like that as well.
And what was your route like into it? Before you even got to the graduate scheme, what did you do before that? And did you always want to be an engineer? Or, when you think back, when you were a kid, was it something you always thought, God, I wish I was an applications engineer working at Renishaw?
Maybe not quite that specific, but I was always interested in, cars and stuff like that. I started off applying to do chemical engineering, didn't quite get the grades to get into that. I think they wanted something like 2 A's or something like that and a B, missed that. So then started on materials engineering course at Loughborough, did a placement year, and then in my final year, I think maybe 6 months before I finished, around Christmas time, I got an offer for the graduate scheme at Renishaw.
So you kind of took your time in that placement year to kind of really understand what the company was about and went back?
I didn't actually do a placement year at Renishaw.
Oh, sorry, yeah.
A company called Satra.
Okay.
But that sort of, it wasn't really that much engineering, but that's where I found my abilities to work hard, I guess, because my first 2 years at uni, I kind of flunked a little bit. But then after my placement year, I came back and smashed my exams and then got on to the grad scheme.
So you said it wasn't necessarily what you wanted out of the placement year, but do you think it's as important to know what you don't want as what you do in
yeah,
job?
Definitely. I would have gone back there if I probably didn't get a grad job anywhere else, just because it's somewhere, it's your foot's already in the door. They loved me. I got along with everyone there. The work wasn't too bad. So you've always got to keep your options open as such. You can't close off anywhere. But I knew that I did want to try something else out.
So what exactly is it about Renishaw that you really enjoy? And, what is it about your job that you really love?
AM as a whole is massively interesting. So starting off doing the plastic printers and then venturing into more of the metal side over the years that I've been there has been great. Every day is completely different. I deal with, upwards of 10 customers a day. I'm project managing a few projects now as well. So it's not just running the machines and stuff like that. I've learned all of that and now I'm applying it on customer parts.
And I imagine, some of our listeners out there are probably avid hobbyists. Is this something that they can do for themselves? Is there stuff that they can do at home? Obviously, you mentioned you can get stuff off the shelf, but do you need a lot of expertise and technical knowledge to make your own 3D bits?
As long as you've got an awareness of design for AM, certainly in metals, you can't have the overhanging surfaces, which I touched on earlier. Or you can, but they just need to be supported, which is then sacrificial material. So this is like a bit of a dirtier side to 3D printing that not many people know about, is the fact that if you do build a part that has an overhanging surface, you end up wasting material, which then adds to your costs because you have to print that material to then get rid of it. So I guess that's a bit of a dirtier side that people don't really think about or know about.
But you can get a lot of these files online, can't you? A lot of people upload kind of CAD model files, don't they? And you can download them and print stuff for yourself.
Yeah. Obviously, those are more aimed at the plastic side of things, I think, online. But there's probably courses out there for additive manufacturing, designed for additive manufacturing.
I'm sure YouTube is your friend on a lot of these things, isn't it?
Yeah, probably.
So one thing I'd be interested to hear your thoughts on is, obviously you work in quite a functional environment in terms of 3D printing. You make stuff for F1 cars and big sailing yachts and whatever. But do you ever think that it might be used in different ways, more artistic ways or stuff like that? You think there's opportunities there?
Yeah, I think there's certainly opportunity for it. We've had, sort of one-off pieces come through, like a purse or a watch bracelet, essentially. But it's a very niche market, and due to the cost of metal printing and the powders that we're using, because everyone, when they go into metal printing, goes, oh, great, titanium. Like, that's like the wonder alloy of 3D printing. We run 4 machines at our new mill site in Gloucestershire on titanium. So it's kind of the go-to. We obviously print a lot of other things, like the nickel superalloys. But I think for other uses, it could be potentially a bit niche for them.
So will you be going to Mars anytime soon? Because I imagine that's the next place where we'll see lots of it, right?
Maybe, who knows? If it makes it onto a spaceship, then that'd be pretty cool.
Because I guess, speaking of that, it's a place like the International Space Station. It's not like they've got a ready supply of tools and bits and bobs, have they can just kind of draw upon, because they're a bit heavy. But do you think they'll be doing 3D printing on there anytime soon?
I'd probably say that they'd be doing more plastic-based stuff. We have quite a lot of consumables and a significant power draw to run the lasers. So you need argon. You also need somewhere to pour your waste. So we have filters in there, because when you're melting metal, you produce condensate, which you need to capture. Otherwise, your print basically goes really bad. So these need to be disposed of in a manner which you can passivate the filter to not cause any explosions and stuff like that.
Explosions? So there's stuff that you've worked with that's a bit dangerous?
Yeah, it's kind of dangerous. I mean, as long as you passivate the filter correctly, which just means pour water in it, basically, then you're okay. But if you don't and you just open it up into the atmosphere, it rapidly oxidizes.
So obviously I touched a bit on it at the start, but is there anything that you shouldn't really 3D print? Like, is there anything stopping you guys from just printing your own money effectively? But I suppose printing a pound coin is probably more expensive in the stuff you're making out of than the actual value of the coin, isn't it?
Yeah, exactly. So our titanium powder, for example, is about £360 a kilo. So to print anything, you could print whatever you wanted, but there would be a cost implication on that.
I mean, yeah, I imagine you're probably going to be losing money if you're printing pound coins out of titanium. Do you think that 3D printing will make its way more into our lives day to day in the future? Do you think there'll be 3D printed bits in our kitchens, in our living rooms, and whatever? Or is it something that's always going to be a bit more niche in terms of high-end, high-tech engineering, or is it going to trickle down?
I think it could potentially trickle down into what I don't know. We're doing a bit of research on heat sinks at the moment, so I'd presume that could end up in sort of our laptops that we're using today. But given the cost that everything currently takes to print, I think it will be a sort of fair way off that.
So have you thought much, or have you given much thought into kind of what your own career progression is going to be, or where you want to be? I like to ask my guests kind of like, where do they see themselves in 10 years time, or what would you say is a good mark in your career 10 years down the line?
God, that's quite a tough one. I'm not really too sure on that. I'd like to become senior engineer within the next couple of years. And well, I currently have 2 direct reports already, so I'm kind of a manager in a way already, but maybe a manager of a few managers potentially. I guess I'll just have to see how it goes, really.
And do you think that there is a bit of pressure on people to become managers and stuff like that? And I appreciate some people that's what they want to do and whatever, but do you think it's as important to enjoy your job and whatever and not worry so much about management progression, or do you think is it worse in an engineering environment, if that makes sense?
I'm a very driven sort of individual, especially career-wise, and hopefully for monetary gain as well. But I think, job satisfaction is huge. So if you don't like your job, then you're not going to enjoy your life as such. But I appreciate that you need to go to work to live in a way as well. But I think it's just generally down to what you want to do. So, some people don't want to progress, but others do. And then, you just leapfrog over them as they don't want to push up any further.
So I like to do a little bit in these podcasts. I've called it Tim's 3 Tips. It's a terrible name. I'm honestly considering changing it because I feel like it's so cringy. But I try to ask my guests who are the experts, let's not forget, to give us some advice on a particular topic, an everyday topic. So I'd love to, if you could tell me, as you're an engineer, and engineering is all about problem solving, could you give me 3 tips on how to solve any problem, an everyday problem?
Yeah, so I think a big one of this is actually writing down what the problem is. So writing it down, it's in front of you. You get to process it a lot better, I believe anyway. I'd probably say number 2 would be, if you can't get it, then, go away, come back at a later date. I used to find that if I was really stuck on something, go home, go to the gym, come back the next day. Generally, you look at it in a different way. And then lastly, I'd probably say speak to your colleagues. So at the end of the day, it's all about working together. So ask them. Sometimes they'll have already come across the problem before. And also your colleagues may be more experienced than you. So don't feel like you need to just plow on ahead on your own. You might be able to get some help on that.
And speaking of kind of working with other people, do you think that it's been harder to be collaborative, in the last couple of months with what's happened? I'm not going to drop the C-bomb, but, obviously it's been a bit of a weird time. And obviously engineering is quite a team-based approach. Has it been hard for you?
I was on furlough for about 3 months of that. But given the amount of sort of nurturing that our machines need, I was back on site relatively straight away after that. And I've been back on site full time since then. So I do see my colleagues, albeit not the whole division, but, the things like Teams, Zoom, stuff like that, we can use to try and get some of that working with others back in our lives as such. But I've been quite lucky in the fact that we are able to be COVID secure and be on site at the same time.
And do you think that aspect is important? Do you think it's important to be kind of face to face with people as best you can? Just more for your own personal well-being as much as for working together in that aspect of it.
Yeah, definitely. I think if you're working at home just on your own all the time, even on Teams, I don't think that's enough to satisfy your inner well-being as such. I definitely think you need some human contact and talking to others, even if it's not about work. You're working away on your computer and then you can have sort of side conversations with your colleagues or your friends.
I certainly miss going to the pub. If there's one thing that I wish would come back sooner, was going to the pub with your colleagues. But there's hope. We have hope now. So I'm excited for 2021. Is there anything that you can tell our listeners about 2021 from Renishaw side, or is it all super, super top secret?
Yeah, it's kind of top secret.
He's actually a spy. He doesn't work for Renishaw. He's actually a spy. So yeah. we'll put that one to bed.
Yeah, there might be a few things coming out. We'll have to see.
Exciting. Matt, it's been fantastic to speak to you today. If our listeners are interested in finding out more about Renishaw, where can they find out, or even find out more about Matt Williams? He's an interesting guy as well. Where can they find out about him as well?
I'm on LinkedIn, so if you search Matthew Williams, you should find me pretty easily on there. I think my title's up to date and everything. Maybe just need to change my photo. About it.
Yes, well, I'm getting the full experience right now for our listeners that don't have video. I'm getting Matt Williams in the flesh, so it's definitely an experience. What about if they wanted to find out more about engineering? Where's a good place to start, and what advice would you give to someone who is potentially considering going to university to do an engineering degree? What kind of stuff would you say is good things, good kind of things to think about before they go, and what stuff really helped you when you were at uni? Sorry, I was asking you a load of questions there.
That's okay. For the first one about getting into engineering, I don't think it's necessarily about doing a degree straight off. Renishaw's got an amazing apprenticeship. People get put through university, their HND, HNC, everything like that. So that's one route into it. And you get the added bonus of no student debt at the end of it. You get a little tie-in period at the end of your degree, but generally you've made money and some more, especially with the amount we're both paying back on our student loans at the moment. Sorry, what was the other one?
I was just saying, if you got any tips or advice for people that are going to go to university, for about their, what's the best use of their time when they're at uni to doing an engineering degree?
Make sure that you're using your time wisely, and like I did in my first year. And make sure you've got some sort of routine down for revising and reading and stuff like that.
Yeah, I mean, I disagree. It's all about partying and having fun. So maybe a happy medium in the middle where you're doing some studying, but you're also enjoying yourself. Matt, it's been an absolute pleasure to talk to you. Stay safe. I hope you have a really successful 2021. And I'll definitely be looking out for Renishaw and all these super duper top secret things you've got coming out when they get released in the future.
Yeah, sounds good. Cheers.
Once again, I want to say a massive thank you to Matt for coming on the show and giving us a really good insight into what Renishaw do. I had no idea they were working on stuff for Formula One and for the America's Cup. It's amazing to think what kind of stuff is now turning into getting 3D printed. You never know, your next bit of kit might be made out of 3D printed parts. As always, if you like the show, please, please, please consider subscribing. It's the best way of keeping up to date with all of our episodes. It'll really help us in the rankings as it'll allow more people to hear about us and share these amazing stories. If you want to get in touch, you can do so by following us on social media at Job Hunter Pod on Instagram, Twitter and Facebook, where you can also find our Job Hunter podcast support group. This is where I'll be dropping most of the links about where you can find out more information about Renishaw and about 3D printing. You can also drop us an email. It's jobhunterpodcast@gmail.com if you fancy having a natter and coming on the show. Thank you very much for listening. I've been Tim French, and I'll catch you next time on the Job Hunter Podcast.